This is lesson 6.5, day 3. We're talking about inscribed angles here. So, the definition of an inscribed angle is basically an angle with a vertex that's on the circle and the sides that are chords. So as you can see right here, an inscribed angle would be this angle right there. We've got our vertex on the circle, and our sides are chords on the circle as well. So that is what your first inscribed angle would look like, and I would call that, if I were to name it, I would call that angle QRS. Okay, an intercepted arc. Now, if I want to talk about an intercepted arc, that would be basically what an arc that's made by an inscribed angle. So my intercepted arc would be right there. It's made from the inscribed angle. So I would call that one QS, and I'd put an arc over top of it if I was writing it. Now in class, we talked about how we would figure out the angle measures of those things. But before we start that, let's talk about a central angle. This is something we talked about yesterday, but it's worth refreshing. Let's say that this angle was 90 degrees. That would mean if I were to label this arc, I would also say that it's 90 degrees. So the central angle equals, the measure of the central angle equals the, let's call it the intercepted arc, I guess. So that angle, the central angle, we call that the central angle versus what we called the inscribed angle. Remember, this is the inscribed angle. Inscribed angle needs to have a vertex on the circle. Vertex on the circle. A central angle has its vertex, obviously, in the center. So those two things are going to be equal. Now, if I go over here, though, this is something that we kind of talked about in class, but this is no longer going to be equal to that angle. In fact, no matter where this is located, so I could have it located there, I could have it located over here, I could even have it all the way over here if I wanted to. These angles, you could check my work with a protractor right here if you really wanted to. But this angle, and this angle are all exactly the same. So it doesn't matter where it's located. I'm going to erase all those now. All we have to know is this. Whatever this angle is, let's say that this was 90 degrees again. My inscribed angle is going to be half of that. So for example, this one would be 45 degrees if that was 90. So anytime you have an angle that vertex is on the circle, it's half as big as its intercepted arc. Okay. So yeah, I guess we could write that out, or you could just have that picture down, but the inscribed angle equals half the intercepted arc. Over here, this is kind of the same situation. If this was our angle that we're talking about, let me make it a little bit easier to see here. If this is the angle we're talking about, and this is a diameter, then basically what that's saying is that's halfway around the circle, which means that's 180 or 180 degrees. Let me fix my marker quick. That's 180 degrees, which means if that's true, if we are making an inscribed angle, it's inscribed because it's got a vertex on the edge of the circle, that would mean this is half, which would make it a 90-degree angle. So the angle inscribed in a semicircle is a 90-degree angle. Okay, so these are some questions from Alex. The first question says, give me an example of an inscribed angle. So an inscribed angle would maybe be, for example, that. So JIH. Would be an inscribed angle. It says give a major arc. So let me erase these. A major arc, this is just an example. I didn't do a very good job there. Let me try again. You get what I'm trying to say here? So it'd be that, going from I to H on the bigger side, making it more than 180 degrees. Now, I had a student ask me a question that said, if I were to write this out, would I have to do I, J, G, H, like that, if it's a major arc? And the answer is no. I don't have to list everything in there. I just need one point that's between there. So I, J, H would do just fine. And I actually should have wrote it over here. I, J, H would be a major arc. Give a minor arc. A minor arc would be, for example, GH. That's smaller than 180. Find the measure of GH is the next question. So we're trying to find that measure. Well, I know that the central angle is the exact same as my circle, or as my intercepted arc. So this would also be 50. Then it also says we want to find measure of GJI, the arc. GJI, this arc right here. Well, I have to read the directions a little bit more closely to figure that out, because it looks to me like that would be a diameter since it's going through the center. So if that's a diameter, then I would have to say that that's 180. There's your first one. Moving on to number 2. It says, suppose the circle below, it says arc FG, that's supposed to be an arc. FG is 114. FG is 114. So that goes from here to there. What does it want? It wants the angle FHG, which would be this angle right there. Since that's the center, I would have to assume that that's going to be the same. 114. And then it says FEG. FEG. So now it's looking for this angle. And the best way I can describe this is if you look at this angle's edges, one of the edges is right there. The other one's right there. And look where it meets. It meets right on the edges of that 114. This is technically an inscribed angle because it's got a vertex that's on the circle. So we would have to just cut that 114 in half. So we would get, well, 114 divided by 2 is 57. So now we're done. Number 3. In the circle below, UW is a diameter, okay? So that's important. This is a diameter. Suppose UV is 48 degrees. That's an arc again. So 48 degrees on the arc. And the measure of UVX is 26 degrees. See if I can zoom in. That would be 26 degrees right there. We are trying to find angle VUW. VUW. That drawing. Let me try again. VUW. That angle right here is one of the ones that we're trying to find, right? So to do that, basically what I need to figure out what this is. And the best way to figure out what that is is to use this 48 degrees and the knowledge that we have that this is a diameter, right? This is basically cutting our circle in half. So if that's a diameter, then everything up there equals 180. So if I take 180 and subtract off 48 degrees, I would get 132, which would be this right here. Let me erase. Now I'm looking for this angle right there, which is an inscribed angle. See if I can get rid of my scribbles here. It's an inscribed angle, so I would have to cut that in half. Now I'd get 66. And for the other one, now we're on B here. It says we have 26. Let me erase my stuff here. We've already dealt with all this, so we don't need that anymore. What I need to know is if this is my inscribed angle, that's 26. If I double that, I'd get 52, which goes right there. That would be from U to X. Now this is still a diameter, so we still got to cut it in half, and it's asking us to find, what is it asking us to find? WVX? WVX. It's asking us to find this angle, right? That's the one that we're trying to look for. So to do that, we would have to take 52 from 180. And we get 128 for over here. And this is our inscribed angle. So now we can divide that by 2 and get 64 for that angle right in there. I would slow that one down and not just write down what I wrote. I would slow it down and make sure you understand every piece of that, because that's a lot of work. It's not difficult, it's just a lot of work. So last couple things here. So now I can't really explain this over the iPad here, but a quadrilateral, if you have a quadrilateral that's inscribed in a circle, then its opposite angles are going to be supplementary. So that means K and M are going to be supplementary. And that means L and N are also supplementary. So you can put supplementary in for all of these blanks, because every opposite angle in there, opposite angles are supplementary like in those. So let's go through this one. It says KLI. That's an arc it's talking about. This arc KLI is 132 degrees. I already know where it's going with this, so I'm just going to take you to the answer. If I divide that by 2, I get 66, and that's going to go in that angle. That's my inscribed angle. For the other one, LKJ, it's giving us that angle. It's giving us 72 right there. So now I've got two angles. I can find my other two angles. All I have to do is subtract them from 180. So 180 minus 72 is going to be 108. And 180 minus 66 is 114. And these are the two things that they're looking for over there, so you'd have to plug those in accordingly. But that's it for this lesson. That's a lot of stuff, but it's not too difficult. My ALEKS assignment, or my ALEKS topics are listed here at the bottom. Thanks for watching.